Good evening to the students of class 12. In the previous video, we have done potential due to a single charge. Now we shall do a potential due to multiple charges. Okay, and in the next page, we shall compare how to approach a numerical for potential and for the electric field due to multiple charges. And in the third page, we shall do the graphs of potential versus R and 1 upon R square. So keep watching the video till the end. I am Dhanu Saraiya with chapter number 2, class 12. Okay, so now first, as a revision part, let us remember what is the potential V due to a single charge Q, where Q is the charge whose potential we want to find out or we have found out, or and R is the distance between the point and the charge. Now here, coming to the diagram, we have multiple charges around a point P. Say Q1, Q2, Q3, Q4, Q5, I can have Qn number of charges. Now, due to this configuration of multiple charges, I want to find out the potential at the point P in the vicinity of these charges. Correct? So, I first find out the potential due to Q1 at the point P. The distance between the point P and Q1 is R1P. So, what is the formula for V1? V1 is equal to K Q1 R1P, where R1P is the distance. Remember, potential is a scalar quantity. Distance between the charge Q1 and P, I am just writing in short. Okay. Similarly, if I write V2, then V2 is equal to K Q2 R2P, where R2P is the distance between Q2 and P. So, in this way I can write for n charges, the potential for the nth charge is Qn upon Rnp. Okay, so these are the individual potentials due to individual charges Q1, Q2, Q3, Q4, so on, Qn at the point P. Now, for finding out the potential at the point P due to this configuration of charges around it, I have to use the principle of superposition, which we have used even in the last previous chapter number 1. What is this principle? For finding out the total charge V, I have to add. For finding out the total potential V at the point P, I have to add the individual potentials due to individual charges at the point P and add them algebraically. If you remember, when we used this principle in the previous chapter for finding out the total E at a point or the total force at a point, we use the same principle of superposition, but we added vectorially. This time, how are we adding them? Algebraically. Okay, that means what we have to do? We have to substitute the charge as it is with the respective polarity of positive or negative and just add all the potentials algebraically. That's what we have to do. Fine. So summation of all this, we can write it as K Q1 R1P plus K Q2 upon R2P plus so on K Qn upon Rnp. So taking the common K, we can write sigma I is equal to 1 to n Qi upon Rip. Okay, where I takes the value from 1 to n and we get all the individual potentials of each charge. So this is the formula for the potential due to a system of charges. Okay, just add the individual potentials algebraically, not vectorially. So to understand the difference between the algebraic summation and vectorial addition, let us look at this concept with the electric field concept of the previous chapter, understanding the concepts by comparing. So you take a pic of what I have derived just now and we shall go to the next page as I said. Fine. Now, as I said, moving to the next page, I have tried to make you understand what is the difference between these two concepts when there are multiple charges. First, let me write down the formula. V is equal to K Q upon R. E is equal to K Q upon R square. This is the potential for a single charge and that is the electric field for a single charge. Correct? These are the formulas. Fine. Okay. Now, when I have a system of three charges, let me say Q, negative Q, 2Q, and I am asked to find out the potential at the centroid O of this triangle, which is equilateral. Fine. So by maths, it is easy to find out these distances which I require there. I can write it as R, R and R because it is an equilateral triangle. Fine. So what is my V here? V is equal to K. Let me write for the first charge Q upon R plus, let me go to this charge K. What is this charge? 2Q. So I write here 2Q upon R. Why am I writing R? Because the distance between the point and 2Q is R. The distance between the point and Q is R. Minus, why I am writing negative here? Because this is the negative charge. So K Q upon R. Simple. Fine, I have written. I will add them algebraically. How should I add them? Algebra. Okay? Algebraically, I have to add them. Or I should use algebra. This is what I have to use. With simple addition. So these two cancels and V is equal to 2KQ upon R. That is my answer for this system of multiple charges. Okay. Now there were three charges here in this system. I have done my work. Same way, let me go to a system of 4 charges, and let me use negative q, positive q, negative 2q, and positive q here. Fine. Okay, I can even write 2q here. Okay, fine. Now I am asked to find out the potential at the point P, which is at the center of this square. Fine. Okay, then with the help of algebra, the distance between the point and charges you can find out. I am not going into the calculation part here. I can write it as x all are equal because this is a square. I can write the distance between each point and charge. The distance between point and each charge is x. Now, how do I add them algebraically? B is equal to, let me talk about the first one, this one. Formula negative kq upon r. Second one kq upon r, this one. Third one positive 2kq upon r. Fourth one, because it is negative 2kq upon r. What is my answer for the potential? 0. That is also possible. Okay? Because these two are same magnitude and opposite polarity, these two are same magnitude and opposite polarity, my answer becomes 0. But my point here is that I have to add the individual potentials algebraically. Just add them with their polarity used. Correct? That type of an addition I have to do when the question is asked for finding out the potential at a point O or at the point P for the system of charges 3 or 4. What should I find out? The potential by this method, adding algebraically. Now let me go to the same type of a question in which I am asked to find out the electric field at the point O and at the point P with the same configuration, Q minus Q, negative Q and 2Q. Okay. Now, again I have to use the principle of superposition. Okay, again I have to use the principle of superposition, but this time I have to add the individual electric fields vectorially. How? Vectorially. So first I have to find out the direction of electric field from the respective charge towards the point. Let us start our work. This I have explained even in the video of chapter number 1, which I am repeating here. So let us begin to draw the direction of the electric field from plus Q towards O. As we know, from positive charge towards the point, go straight downwards. From positive charge, whatever its value may be, go towards the point, go straight. Let me name this as E1, let me name this as E2. Now here this charge is negative, so from the point I should come towards the charge. Let me name this as E3. Okay, now how should I add E1 and E2? By using the parallelogram law of vector addition. So let me write E1 plus E2 plus E3 using superposition principle. How should I add these two? I should add these E1 and E2 using parallelogram law of vector addition. You can see the direction, one is like this, one is like this. So they are the adjacent sides of the parallelogram. And E4 is the resultant of E1 and E2, which I am writing here. And E3 is also in the same direction as you can see. So I have to just add them. Correct? I am not entering into how to use the parallelogram law of vector addition. What is the parallelogram law of vector addition? E4, which we are finding out, magnitude is equal to E1 square plus E2 square plus 2 even E2 cos theta between them. This is the E4's formula. Fine. Okay, I didn't have space, so I've written down. It is understood. Fine. Now, same way, what should I do for the same configuration which I have put here? I will put here also, I have put here also, and find out the individual electric fields direction and add them vectorially as done here. Fine. Okay. So now start from here. Point towards the charge. Let me name is this as E1 for plus Q from the charge towards the point. This is E2 from the charge towards the point. This is E3 and this is negative. That's why from the point towards the charge, this is E4. Fine. Okay. Now, what is my vectorial addition again? E is equal to E1 plus E2 plus E3 plus E4. I have to add these electric fields vectorially. How do I add them? Find out individually. And because E1 and E3 are on the same line, I add them. And E2 and E4 are also on the same line. So I add them directly after finding out their values. And the resultant of these two, as can be seen, is here. This is the resultant of the addition of E1 and E3, E2 and E4, add them vectorially using parallelogram law of vector addition with the angle as I showed you. Fine. So, for finding out the electric field, we have to use this procedure of vector addition. And for finding out the potential due to charges, I have to just add them algebraically. Understand the difference? That's why I have shown the comparison. Fine. So, understand and take a pick, and I shall move now so that you understand the procedure properly and take a pick. Now, let us go to the next page. As I have declared in my video that I will do some graphs of V. So first let us write down the formula of the potential due to a single charge. Fine. Okay. So let us write its proportionality. V is inversely proportional to R. How do I read it as? V inversely proportional to R. I can also read it as V directly proportional to 1 upon R. These are the two ways of reading any graph. V inversely proportional to R or V directly proportional to 1 upon R. So those graphs we are going to do. So let us first do V inversely proportional to R. If V is inversely proportional to R, it is according to the formula a negative curve. Fine. Now, if at all Q greater than 0, we get this type of graph. Now, if Q is less than 0, for V inversely proportional to R, as read here, we have to draw the same kind of graph but in the fourth quadrant. So remember, what are they asking? Q greater than 0 or Q less than 0? Q is positive or Q is negative? Fine. Okay, remember that. I can write this as capital Q if there is some confusion for you to remember or understand. Okay? Q is a capital Q. Fine. So if Q greater than 0 and I read it as V inversely proportional to R, you have to very much be careful according to what is given in the y-axis and x-axis, and accordingly you have to draw the graph. Okay? Now, for Q less than 0, that is the charge is negative, same axis, x-axis is R, y-axis is V, draw this kind of a graph. Now, for Q greater than 0, what is there on the x-axis? 1 upon R. And how can I read 1 upon R? V directly proportional. So how should I write? V directly proportional. Draw this way. Fine. Provided Q greater than 0. Now for Q less than 0, Q is positive, here Q is negative. How should I draw a graph? I should draw the same graph, a straight line graph from the center, but in the fourth quadrant, provided Q is less than 0. So be very careful of what is asked. Q greater than 0, x-axis is 1 upon R. Q less than 0, x-axis is 1 upon R. Here Q greater than 0, x-axis is R. Q less than 0, x-axis is R. Read it. Inversely proportional, directly proportional. If inversely proportional, negative graph, but change the quadrant according to the polarity of Q. Similarly, change the quadrant according to the polarity of Q, provided V versus 1 upon R is asked. Very tricky questions can be asked, but your eye should go on the x-axis and go to the formula. Then you will be clear and you will do the correct marking of the graph. Every year in entrances this kind of graphs are asked. Don't get confused. Be clear with how to go about. Go to the formula, remember the proportionality. Your eyes must go on the x-axis and your eyes should also go on the polarity of the charge. Then you can understand the quadrants. Clear? Okay? So just take a pic and understand what I have tried to convey through these graphs. Fine? Okay. Now in the same graph, they can also ask for E for this kind of questions or for this kind of graphs. Then how should I do? I will put it with a yellow curve. Okay, this is the graph for E, and here also I go little front and then I cross here. Go little front and then I cross here. This is the graph for E versus R. This is the graph for E versus R on the same axis. This is also asked. So take a pic of this also. Fine? I just move.